Good morning. Today we are going to do Bayes classification, naive Bayes classification. In last class we have already seen Bayes theorem. So just to remind you of Bayes theorem, what is Bayes theorem? Probability, conditional probability. So probability of A given B. Okay, so B has already occurred. What is the probability of A occurring after B has occurred? That was, we saw it is equal to probability of B given A into the prior probability of B divided by the prior probability of A. And that is where we had stopped in the last class. Now today we are going to look at how classification is done using this Bayes theorem. Before we do the classification, naive Bayes classification, let's just look quickly at the derivation. ഇന്നലത്തെ ക്ലാസ്സിൽ ഞാൻ പറഞ്ഞായിരുന്നു, ഞാൻ ഡെറിവേഷൻ കാണിച്ചു തരാമെന്ന്. വളരെ സിമ്പിൾ ആണ്, നമുക്കറിയാവുന്ന കോൺസെപ്റ്റ്സ് തന്നെ യൂസ് ചെയ്തിട്ടാണ് ഇതിന്റെ ഡെറിവേഷൻ നമ്മൾ ചെയ്യുന്നത്. ഓക്കെ, സോ ഫസ്റ്റ് നമ്മൾ ബിഗിൻ ചെയ്യുന്നത് ഇന്നലെ സ്റ്റാർട്ട് ചെയ്തതുപോലെ തന്നെ കണ്ടീഷണൽ പ്രോബബിലിറ്റിയുടെ ഫോർമുല യൂസ് ചെയ്തിട്ടാണ്. സോ യെസ്റ്റർഡേ നമ്മൾ കണ്ടായിരുന്നു, പ്രോബബിലിറ്റി ഓഫ് എ ഗിവൺ ബി ഈസ് ഈക്വൽ ടു probability of A intersection B divided by probability of B if the probability of B is not equal to 0. കാരണം probability of B ആണ് the prior probability. എന്നുവെച്ചാൽ probability A given B എന്ന് വെച്ച് കഴിഞ്ഞാൽ B നടന്നു കഴിഞ്ഞിട്ട് A നടക്കാനുള്ള ചാൻസ് ആണ് നമ്മൾ ഈ കാൽക്കുലേറ്റ് ചെയ്യുന്നത്. B A നടക്കാൻ ചാൻസ് ഇല്ലെങ്കിൽ പിന്നെ probability A B കഴിഞ്ഞിട്ട് നടക്കുന്നതിന്റെ ചാൻസ് ഇല്ല, അത് പിന്നെ കാൽക്കുലേറ്റ് ചെയ്യേണ്ട ആവശ്യമില്ല. അതുകൊണ്ടാണ് ഇഫ് പ്രോബിലിറ്റി ഓഫ് ബി നോട്ട് ഈക്വൽ ടു 0 എന്ന് ഇന്നലെ ഞാൻ പറഞ്ഞു തന്നായിരുന്നു. ഇവിടെയാണ് നമ്മൾ സ്റ്റാർട്ട് ചെയ്യുന്നത്. ഇനി നമുക്കറിയാം പ്രോബിലിറ്റി ഓഫ് എ ഇന്റർസെക്ഷൻ ബി എന്ന് പറയുന്നത് ഇസ് ഈക്വൽ ടു ദ പ്രോബിലിറ്റി ഓഫ് ബി ഇൻ ടു ദ പ്രോബിലിറ്റി ഓഫ് എ ഗിവൺ ബി. എയും ബിയും ഇന്റർസെക്ട് ചെയ്യാനായിട്ടുള്ള ചാൻസ് എന്ന് പറയുന്നത് ബി ഒക്കർ ചെയ്തു എന്നിട്ട് ബി കഴിഞ്ഞിട്ട് എ ഒക്കർ ചെയ്യുന്ന ചാൻസ്, അല്ലെങ്കിൽ ഇറ്റ് ക്യാൻ ഓൾസോ ബി റിട്ടേൺ ആസ് എ ഒക്കർ ചെയ്തു എന്നിട്ട് പ്രോബബിലിറ്റി ഓഫ് ബി ഒക്കറിങ് ആഫ്റ്റർ എ. ഓക്കെ, അപ്പൊ ഏതെങ്കിലും രണ്ടും നടക്കണമെന്നുണ്ടെങ്കിൽ ഒന്നെങ്കിൽ എ കഴിഞ്ഞ് ബി നടക്കണം, അല്ലെങ്കിൽ ബി കഴിഞ്ഞ് എ നടക്കണം. അപ്പം പ്രോബബിലിറ്റി ഓഫ് എ ഇന്റർസെക്ഷൻ ബി എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ബി നടന്നു കഴിഞ്ഞിട്ട് പ്രോബബിലിറ്റി ഓഫ് എ നടക്കാനായിട്ട് ഉള്ള ചാൻസ് ആണ്, ബി നടക്കുന്ന ചാൻസ് ആണ് പ്രോബിലിറ്റി ഓഫ് ബി. അത് കഴിഞ്ഞ് എ നടക്കണമെങ്കിൽ പ്രോബിലിറ്റി ഓഫ് എ ഗിവൺ ബി. ഓക്കെ, ഇൻറ്റു ഇനി തിരിച്ചാണെങ്കിൽ ആദ്യം എ ആണ് നടക്കുന്നതെങ്കിൽ ദെൻ പ്രോബിലിറ്റി ഓഫ് എ ഇൻറ്റു ആഫ്റ്റർ എ ബി നടക്കുന്നതിന്റെ പ്രോബിലിറ്റി. സോ പ്രോബിലിറ്റി ഓഫ് ബി ഗിവൺ എ. അപ്പം ഏത് കാൽക്കുലേറ്റ് ചെയ്താലും നമുക്ക് പ്രോബിലിറ്റി ഓഫ് എ ഇന്റർസെക്ഷൻ ബി കിട്ടണം. അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ വി ക്യാൻ ഇക്വേറ്റ് ബോത്ത് റൈറ്റ് ഹാൻഡ് സൈഡ്സ്. ബോത്ത് റൈറ്റ് ഹാൻഡ് സൈഡ്സ് നമ്മൾ ഇക്വേറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ പ്രോബിലിറ്റി ഓഫ് ബി ഇൻറ്റു പ്രോബിലിറ്റി ഓഫ് എ ഗിവൺ ബി മസ്റ്റ് ബി ഈക്വൽ ടു പ്രോബിലിറ്റി ഓഫ് എ ഇൻറ്റു പ്രോബിലിറ്റി ഓഫ് ബി ഗിവൺ എ. ഇതിൽ നിന്നും നമ്മുടെ ബേസ് തിയറം ഓട്ടോമാറ്റിക്കലി കിട്ടി. പ്രോബിലിറ്റി എ ഗിവൺ ബി ഇസ് ഈക്വൽ ടു പ്രോബിലിറ്റി ഓഫ് എ ഇൻറ്റു പ്രോബിലിറ്റി ഓഫ് ബി ഗിവൺ എ ഡിവൈഡഡ് ബൈ പ്രോബിലിറ്റി ഓഫ് ബി. ആൻഡ് ദിസ് വാസ് അവർ ബേസ് തിയറം. സിമ്പിൾ ആയിട്ടുള്ള ഒരു ഡെറിവേഷൻ ആണ്, ഇതിൻ്റെ അകത്ത് ഒരു ഡിഫിക്കൽട്ടിയും ഇല്ല. മനസ്സിലായി എന്ന് വിചാരിക്കുന്നു. ഇനി നമുക്ക് ബേസ് ക്ലാസിഫിക്കേഷനിലേക്ക് കടക്കാം. Okay, now when we do naive Bayes algorithm, the first thing that we need to know is it can only be done under two circumstances. Two of these circumstances, that is what I have written here as assumptions. When we are applying naive Bayes classification, we are assuming that these two conditions are true. Okay, first condition is that all the features are independent. If you remember, yesterday I told you that the probability of A intersection B, in the case that A and B are independent, is probability of A into probability of B. This is our assumption. We are assuming that whenever we look at two features, those two features are independent. Okay, and we are making another assumption that every event is class conditional independent. Okay, so features are independent, one assumption, and
there is class conditional independence. That means an event that occurs within a particular class are all independent to each other. It's not always true, but in many of the real world applications it is true. Only if these two conditions are satisfied, we can apply naive Bayes algorithm. Okay, now assuming that those two conditions are true, let a data set sample that we have, let us assume that our data set sample, this is general, this is in general, after in general we will do in detail. So let us assume that we have a data set with capital N number of samples, and each sample has got n features. So the attributes is small n. So my feature vector will have n attributes or n elements, and if there are p classes, okay, so we can do bi-class models, that is two class models, or we can do multi-class models. So if we have a multi-class model, this is a general case. So if there are p classes, then we will have C1, C2, etc. Cp. So if these two are true, then for testing whether an instance, new instance x given by x1, x2, etc. xn is belonging to which of these classes, we want to test whether this x belongs to which class. In that case, we will simply compute, given x, what is the probability that the x belongs to C1. Next, we are looking at, given x, what is the probability that x belongs to C2. In this way, we will do for all of the p classes. Find the probability for each of the classes. Whichever probability is the highest, that is the probability to which we are going to assign this particular class. Now, we are seeing naive Bayes classification. What I told you is that we simply have to find the probability of that particular x occurring in each of these classes. Now, how will we do that? We are applying Bayes theorem. Okay, so we have to find out the probability of Ck, where k ranges from 1 to p, because we have p classes. So when k ranges 1 to p, we have to find probability of the class of x belonging to class Ck, where k ranges from 1 to p. Okay, now this is the same as probability of b given a. What was probability of b given a? Probability of a given b into probability of b divided by probability of a. That was our formula. So just substitute the values. Here this is b and this is a. Okay, so if I have probability of b given a, it is simply probability of a given b into probability of b divided by probability of a. Okay, so wherever we have a, we will be having x over here. Wherever we have b, we will be having Ck over here. So we have probability of Ck given x is equal to probability of x given Ck into probability of Ck divided by probability of x. Okay, now look at this over here. Probability of x given Ck, you remember I told you earlier that x is a vector of n features. So we actually have x is equal to x1, x2, etc. xn. This was our x. So to find for each of these values, we have to, if you remember, I showed you generalized Bayes theorem last time. So each of these values are independent. We also know that the features are independent. Since the features are independent, the probability of capital X into Ck is simply probability of x1 given Ck into probability of x2 given Ck, etc. into probability of xn given Ck, because it is independent. Okay, now in that case, this probability of Ck is directly proportional to probability of x Ck into Pck, because this value, the probability, this value is directly proportional. This is the numerator, so it is directly proportional to Ck given x, and this probability of x occurring will be ignored. So in that case, to find out if this particular value has to be maximum, okay, we want to find the value maximum. Whatever this number, only if this number is large, when I do the division, I will get a large value. So in effect, do you understand? What I'm trying to say is, if I have got 10 divided by 2, 30 divided by 2, this is fixed. Probability of x is fixed. Okay, 50 divided by 2, which answer will be the highest? Obviously 50 divided by 2, because I have a more amount of data is being divided by 2. Here less amount of data is divided by lesser than this is this. Okay, so if I want to find out of these which is going to be the highest, it simply depends on the numerator value. That is what I mean by over here. Since we have division by a common value, to find out which of these k classes, when we do the probability, it will be maximum, all I need to find out is this particular value. Okay, whatever the value of px may be, if this value is maximum, that is the class value which is going to be maximum. Probability of that class will be maximum. So instead of doing division and all that, we are simply going to find out, to find to which class this particular x belongs, I'm simply going to find out which is the maximum of this value. So I will calculate the probability for all k's from 1 to p in this way. Probability of x1 given ck, probability of x2 given ck, etc. Probability of xn given ck into probability of ck, that is the numerator. And I will do that for all the p values, and then whichever is maximum, that is the k to which this particular x will belong. Okay. Now for calculating the probability of ck, you all know this already, prior probability you all have done in maths. The total number of samples, that is in our case n, capital N, divided by the number of samples which has got ck value. This belongs to class ck. Okay, so number of samples belonging to class k. Okay, that divided by the total number of samples is probability of ck. Okay, and then we need probability of xj given ck. Okay, so here out of the samples, okay, out of the there is this number. Okay, out of the samples, whichever class, say that I had 5 samples belonging to the class 2. Okay, out of these samples, how many samples have 1 as the value, that is the jth feature has the value 1. Okay, so number of samples with jth feature equal to this value. If it is 1, then 1. If it is 0, then 0. Okay, or if there are more than, if they are not just binary values, then if there are more 1, 2, 3, 4, 5, then each of them, that is what you have to calculate. And the class label is in class k. Okay, because this is ck. Within that class k, how many of the jth attributes has this particular value, divided by the total number of samples in class k. Okay, this is the way we will calculate probability of ck and probability of xj ck. Now let us look at a problem. Consider a training data set. Okay, so we have a training data set. Consisting of the fauna of the world. Each unit has 3 features. So the data set has 3 features: swim, fly and crawl. Okay, features. Each of the each instance has 3 features: swim, fly and crawl. Okay, the attributes or values that are possible for each of these attributes are: for swim we can have either fast or slow or no. Okay, does not swim. For fly we can say long distance, short distance, rarely and no. Okay, does not fly. And in the case of crawl, yes or no. Okay, so each unit, each of the instances are classified either as animal or bird. Okay, so sorry, animal or bird or fish. Okay, so there are 3 classes, 3 attributes. Each attribute has got, this attribute has got 3 possible values, fly has got 4 possible values and crawl has got 2 possible values. Okay, now what we need to do is using the naive Bayes algorithm. So we have to use the naive Bayes algorithm to classify a particular species if its features are, so our X is given to us with swim has got the feature slow, fly has got rarely and crawl is no. So given this as the test instance, is this particular X belonging to animal, to bird or to fish? This is our question. Okay, now we need the data set. So now this is the data that we have. Now as we saw earlier, what was our requirement? We were given the test data X, where the first attribute swim was slow, fly was rarely and crawl was no. And we are asked to find out whether this belongs to class animal, bird or fish. So let's assume C1 is animal, C2 is bird and C3 is fish. Okay, so this is for C2 and this is for C3. I'll get there. Okay, so remember, animal is C1, bird is C2, class 2 and fish is C3. Okay, now according to our Bayes theorem, to find out probability of X given a particular class, what we need, because it is directly proportional, all we need to find out is probability of slow given this class, probability of rarely given this class, probability of no given this class into the probability of the class. So for all the 3 classes we need to find out this particular value. Now to do that, let's first find out the prior probabilities. Okay, now prior probability of C1, that means the probability of, we have got 12 of these instances. So out of the 12, how many belong to class 1, animal? That is 1, 2, 3, 4 and 5. So this probability over here C1 is 5 out of 12. Okay, now how many belong to bird? That is the class 2, 1, 2, 3 and 4. So we have 4 out of 12 belonging to class bird. Fish, 1, 2, 3. So we have 3 out of 12 belonging to class 3. Okay, so the prior probabilities we already know, the number of instances in that particular class divided by the total number of instances. That is our probability of C1, C2 and C3. Okay, that is done. Now we need to find out, I am going to do only for class 1. Okay, and then we will just substitute the values as it is over here. Okay, so for probability of in class 1, we already have the conditional probability where C1 is already given to you. So we already know that out of the 5 which is in class 1, how many of them has the first attribute equal to slow? Okay, so these are the 5 class 1s. Out of that, the first attribute over here, this one is slow, and over here this one is slow. So out of the 5, only 2 has got the swim attribute slow. So probability of slow given C1, swim is equal to slow given C1 is 2 out of 5. Now how many are rarely flying out of the animals? All these 3 are no. Only 1 out of the 5 are rarely flying. Out of this 5, how many are no for crawl? Animal. 1, 2, 3. 3 out of the 5 are no for crawling. Okay. Now all we need to do is substitute these values. So we have 2 out of 5 into 1 out of 5 into 3 out of 5 into 5 out of 12. Okay, so if you do the calculation, it will come up to be 0.02. Similarly, you need to do for each of this. Now in class 2, you need to find out slow in class 2, bird. Okay, so 1, 2, 3, 4. Out of these 2, there are no slow. Out of these 2 also, there are no slow. So this value, the first value is equal to 0. Any one value which is equal to 0, it will make everything 0. So this probability is 0. Okay, now let's look at this. Probability of slow in class 3, swimming slow. Okay, so this is fish, this is not slow, this is fish, here we have slow and here we have slow. So 2 out of 3. So this is 2 out of 3 into probability of rarely into C3. Okay, again this is not rarely, this is not rarely, and this is also not rarely. So that becomes 0. So this also, the probability is 0. So now what have we got? Both of these probabilities have turned out to be 0. So this particular instance belongs to class 1 because this is the only one which has got a particular value. So the class is animal for the given example. Okay, this is how we apply Naive-Bayes theorem. And with this, I am concluding today's class. We will see more on Naive-Bayes tomorrow in the next class.